sets, set operations, set identities, and lots more. The first question we have here, we have in the sequel N, Z, and Q denotes the set of all natural numbers, the set of all integers for the N, and the set of all natural number for N, the set of all integers, and the set of all irrational number. Exhibit in tabular form. Exhibit in tabular form. We have the first one, set A equal to set of X such that X belongs to all natural numbers. And then we have the equation, which is a quadratic equation. So the first thing we do is to solve this quadratic equation, x squared minus 5x plus 6 equal to what? Equal to 0. As we all know that quadratic equation, we can use a factorization method to solve it. We can use a formula method to solve it. So I'm going to use a factorization method to solve it. This one times this one, that's a plus 6x squared. And then the factors of 6 that can give us minus 5. That will be, we can use 6 and 1, and we can also use 2 and 3. So 2 and 3 will be appropriate in this case. Minus 2, minus 3. And then you can pair your x. Okay? So this will now become x squared. Then replace this one with those two numbers. Minus 2x, minus 3x, and then plus 6 equal to 0. Then pair this, pair this. Here, x is common. Take it out. Then we have x minus 2. Here, 3x and 6, 3 is common. Take it out. We have x minus times plus, that's minus. How many times 3 goes in 6? That's 2 times equal to what? Equal to 0. And when you factorize this and this must be the same thing. You take one of that, okay? Then x minus 3 equal to 0. So this is equal to 0. This is equal to 0. So x is equal to what? 2 or what? Or 3. So our answer will now become A is a set of what? A is a set of 2, 3. That is the natural number. Okay, that is the natural number. As we all know, natural numbers are all numbers excluding 0. Then the B parts are y, b equal to set of y such that y is a member of this as z, this symbol. And this symbol is set of all integers. And we have the quadratic equation. We have 2y squared minus 3y plus 1 equal to 0. So let's solve that. That's a plus 2y squared. Two factors of this will be 2 and 1. So how do we use 2 and 1 to generate minus 3? That will be minus 2, and minus 2, minus 1. So we can pair the y, so that will be y. So this one will turn to y. So we now have 2y squared. Replace this one with these two numbers. Minus 2y minus y plus 1 equal to what? Equal to 0. Then pair this one, pair this one. 2y is coming. Take it out. Then we have y minus 1. Here, y and 1 minus 1 is common. And we have y minus 1 equal to 0. So this one gives us y minus 1 into bracket what? 2y minus 1 equal to 0. So this implies this expression y minus 1 is equal to 0. 2y minus 1 is equal to 0. So y is equal to 1 or 1 over 2. So that's what we have in that case. So we can now write the set B now. Set B is a set of what? we are told all integers. All integers. As we all know, integer also is a whole number. It could be positive, it could be negative, or zero. So it's a whole number. So the half is knockout. The half is not an integer. The C parts, the C parts, set C equal to x such that x is a member of Q, and this Q is irrational number, set of irrational number. So let's see the quadratic equation we have there. We have 6x squared minus 13x plus 6 equal to 0. Let's do our factorization. Factorize, that'll be this one times this one, that's plus 36x squared. Two factors of 36 that can generate minus 13. That will be 6 and 6. 6 and 6, but 6 and 6 cannot generate minus 13. 12 and 3 also is also a factor, but it cannot give us minus 13. 9 and 4. 9 and 4 will give us minus 13, and that will be minus 9 minus 4. Okay? So, and when you multiply these two together, it's going to give you plus 36x squared. So you can replace the center one with the two factors, and that will be equal to 6x squared minus 9x minus 4x plus 6 equal to what? Equal to 0. Then begin to pair it, this one and this one. Here and here, what's common? 3x is common. So we have a 2x minus 3. Between 4x and 6, minus 2 is common. So we have x minus 3. We have 2x minus 3 equal to 0. So when you factorize, these two must be the same. Take one of that, and then 3x minus what? Minus 2. So 2x minus 3 is equal to 0. Uh, 3x is out here. We have 2x. Yeah, that's correct. So that's correct. Equal to 0. So this will give us x equal to 3 over 2 or 2 over 3. So that's what we have for the C parts. That's what we have for the C parts. That's 2 over 3. So that means set C is a set of what? Set of 2 over 3, 3 over 2. Okay, so that's that on the irrational number. Irrational number is a fraction. It could be fraction, it could be decimal. So that's that on the C part. That's a set of irrational number. Let's go for the D part. For the D part, set D is equal to x set of set D equal to set of y such that y is a member of what? Of irrational number. And we have the quadratic equation. Okay, we have the quadratic equation. I think we can quickly manage this place to solve that. Okay, let's use another space for that. We have s squared. We have x squared minus x plus 1 equal to 0. So if you look at this quadratic expression, we can't factorize it, but we can use quadratic formula. Okay, if you correspond this equation to general quadratic equation, this is a general quadratic equation. Correspond it together. A is equal to 1, B is minus 1, and C is what? C is 1. So we can use the quadratic equation minus B plus or minus B squared minus 4AC all over what? All over 2A. Okay? So in that case now, my B is what? Minus 1. So that'll be 1 here, plus or minus B squared, that's 1, minus 4 times A is 1, times C, my C is also 1, over 2 times what? 2 times 1. A is 1, So we have 1 plus or minus, that's 1 minus 4 over what? Over 2. So if you do that, we're going to have what? We're going to have 1 plus or minus root minus 3 over what? Over 2. Okay? And this one, minus 3, root minus 3 will give us what? Root minus 1 times what? Root minus 3, which is what? This one will give us I, which is a complex what? Complex number. So we now have for that 1 plus or minus root 3, the complex number over 2. Okay? So in that case now, a complex number is not an irrational number. So set D will be equal to what? An empty set. Okay, or you can write as what? As this. Set D is an empty set. So that's that on question 1. Let's quickly go to question 2. Let's go to question 2. We have in this question 2, we have let A be set of A, comma B, comma C, comma D, comma E. We have B set of A, D, E, F, and G. And we have C, A, comma C, comma E, comma F, and comma H. So we have to find the first one, A intersects B. Okay, that's the first one. The second one, A intersects C. The third one, A intersects B intersects C. So let's quickly go to the first one. The first one, let's look at that. The first one, which is what? Which is the first one, A intersects B. Okay, A intersect B. A intersect B. Intersection means the common elements that you can find in A, and at the same time you can. So if you look at this one now, A is there, A is there, so it's common. So that'll be A. Okay, then the next one is what? E is here, E is also here. It's common. That's it. Okay, and that's that for the intersection. That's that for the intersection. So A intersect B is what? Is set of A comma E. The second one, A intersects C. Let's see the value for that. A intersects C. If you look at it, A is there, A is there. Okay. Then the next one, C is here, C is also here. Okay. Then the next one, any other one again, E is here, E is here. Okay. So that's that. D is here, but D is not in C. So that's the intersection between set A and set C. Okay. Let's look at the third one. The third one, B intersects C. B intersects C. I think please do this one and put it on the comment section. Let me see the answer for that on the comment section. B intersects C. Okay. Then I'll go to D part. I'll go to union. A union B. Union, we use this symbol for union. We use U for union. And what does that mean? What does that mean? Before I go on, please, I want to welcome you to this channel. Here for the first time, please smash the subscribe button. Okay, so that you're able to send your live question. Okay, and I promise to respond to all those questions, and if possible, to make a like section of your questions. Okay. A union B. Union means the combinations between the two sets. It could be 3 sets. The combinations between the sets. So we're going to look at union now. A union B is going to be what? A union B is equal to all the combinations A, and let's now make it to be in ascending order. A, comma B, comma C, comma D, comma E, F, and G. So that's the A union B. the elements in A, and at the same time, the elements in B. That's the union. That's the union. Then we go to the E parts. We go to the E parts. Welcome once again. Welcome for those that for the returning viewers. I want to say you are powerfully welcome. Okay, what you can do for me is what? Click on like button. Okay, and begin to send the links of these live live video to all your social media platform. Okay, make it a multiplier effect. Thank you for doing that. The E parts, we have A union C. A union C is a combination of elements in A and element in C. A union C is a combination of elements in A and elements in C. But there must not be repetition. So we're going to have set of A is there, A, B, C, D, E, F, and H. That's the combination. That's A, B, C, D, E, F, and H. That's your A union C. That's A union C. Okay. A union C. A, B, C, D, E, F, and H. Okay. Can we go to F, B union C? B union C. Please also, I want your comments. Put for the answer for B union C. Put it on the comment section. Okay, let's see your B union C. And that will be combinations of elements in B, element in set B, and element in set what? Set C. I'll go to G now. G, want to find A union B. Okay, union C. A union B, union C. The first thing I would do is to get the A union B, which we've gotten before. That's what? That's A, comma B, comma C, comma D, comma E, comma F, and comma G. That's my A union B. And then union C also. My C, I'm going to write the C. My C is what? A, comma C, comma E, F, H. So let's now combine the two sets together. So that will be equal to what? That will be equal to A, B, C, D, E, F, G, H. That's the union between A union B and set C. So that's that on that. Let's go to the H. A intersect B intersect C. Okay, you can do it once or you can do it twice. You can get the intersection first. A intersect B. Let's check A and B. What is common there? And I think we've gotten that before. That's A, comma E. A, comma E. So this that's the A intersect B. And then the element of C, let's write it. That's we have this A, comma C, comma E, F, and H. So now find the common elements. A, comma E, A, comma E. So that would be what? That's the intersection for that question. And that will take us to I. A intersects B intersects C. In that case, now we're going to list the element of A, which is what? A, comma B, comma C, comma D, comma E. And then B intersects C. B intersects C. Okay, that's all I gave us for the comment section. But let's do that together. B intersects C. Want to find the common elements between B and C. What is common in that place? What is common in that place? We have A is common. A is common. E is also common. F is also common. So that's what we have for B intersect intersects C. Okay, then that will give us what? That will give us A is here. A is here. We're going to write it. E is here. E is also here. F is here, but F is not here. So that's our answer for that place. That's our answer for that place. Welcome on board. Welcome, welcome, welcome. You are in the right place. If you are just coming in, please smash that subscribe button. Okay? Don't do it. Don't do it later. Do it now. Subscribe now. Okay, so that you can what? You can be part of the what? Of the commentator of this channel. You can forward your question. You can give us a thumbs up. Okay. You can forward your life questions, your different question, apart from the one I'm solving now. Okay. So welcome on board. And for those that are returning viewers, I want to say kudos to you. Thank you for always coming on board. Okay. What you can do now is what? Keep watching. Okay. Send the links of this channel to all your social media platforms. Okay. Don't stop there. Make it a multiplier effect. Okay. Thank you for doing that. So the last question here for question 2 is this one. J is A union B intersects C. We're going to list the element of A. The element of A, we have this. Union B intersects C. We have this A comma E. So combine them together, as you know that union is what? The combinations of the two elements. So that will be equal to what? A comma that will be set of A comma B comma C comma D comma E. So that's the answer for that question 2. Welcome, 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 welcome. Okay, welcome on board. Welcome on board. So the next thing we want to look into now is what we call the complements. We want to look at the complements and identity. Complements and verifying identity. Okay. We have this question. We have U. That U is a universal set, and it's a set of what? 1, 2, 3, up to 10. Those omitted value mean 4, 5, 6, 7, 8, 9, 10. The X, that's 2, 4, 6, 8. We have the Y, that's there, 1, 2, 3, 4. And we have the Z, that's 3, 4, 5, 6, 8. And we are told to exhibit in tabular form the set X prime. X prime mean X complements. Y prime mean Y complements. Y prime mean Y complements. Z prime mean Z complements. So let's quickly get those values. When you are finding your S complements mean we are going to remove the element in X from the universal set. Remove the element in X from the universal set. 2 is there. So we have the remaining elements is what we call the complement. That'll be 1, that'll be 3, okay, that'll be 5, that'll be 7, that'll be 9, and that'll be what? That'll be 10. That's your that's your S complement. You're going to take all the elements in this place, take it away from the universal sets. Then let's get the Y prime, which is a Y complement. Okay, Y complement. This Y complement can also be written as what? As Y to power C. The two of them make complements. You're going to remove the element of Y from the universal set, and that will remain. You're going to have 5, 6, 7, 8, 9, 10. That's the Y complement. And then the last one, that's the Z complement. You're going to remove all the elements in Z from the universal set, which is 1 to 10. So that will give us what? That will give us 1, 2, 2, 7, 9, and 10. So that's the Z or Z complements. Remove all the elements in Z from the universal set. That will be 1, 2, okay, 7, 9, and 10. So that's that on the complements of a set. Okay. Then the last one we want to look into. But before that, I want to welcome you powerfully. Welcome to this channel. If you are here for the first time, please smash that subscribe button. Click on it right now. This is the best time to do that. Click on it now. That is one of the ways to advance this channel. What are you waiting for? Okay, click on it now. And I want to also encourage you to take your journal, your pen, and begin to work along with me. Don't stop there. Click on like button. Type your comments. And if you have any different questions, okay, different from the one I'm doing here, you can forward it on the comment section. And I promise to make a live section of those questions. And then for the returning viewers, I want to say kudos to you. I want to give you kudos. Thank you for always coming on board. Okay? Give us a thumbs up and share the links of this video on all your social media platforms. Make it a multiplier effect. Let your friend also do likewise. Thank you for doing that. We're told to verify the identity to show that X union Y complements is equal to what? Is equal to S complements intersect what? Y complements. That's what we are trying to show. And that's very simple. That's very simple. The first thing we are going to do, we are going to start from the left-hand side. When you are told to verify, what you do is to confirm. Is your left-hand side is equal to the right-hand side? And that's what we want to do in this case. The left-hand side, let's get that. S union Y, let's get that first. S union Y, we got to what? S union Y, that's combine the elements in X and Y together. That 1, 2, 3, 4, 6, 8. Then get your what? Get your X union Y complements. So remove this X union Y from the universal sets. And if you do that, you're going to have 5. You're going to have 7. You're going to have 9 and 10. And that's that for the X union Y complements. And for the right-hand side, we want to combine X complements intersect Y complements. This will not take us time. We've gotten our X prime and Y prime. Okay, let's find the intersection between those sets. 5 is common here. 5 is here. So we take it. 7 is here. 7 is here. We take it. 9 is here. 9 is here. We pick it also, and finally 10 is also common. So check the value. You can see the what? Your right-hand side, X union Y prime complements is equal to what? S X prime intersect Y prime. So that is very, very correct. And actually, this is the De Morgan theorem. It's actually correct. Let's check the second one. I want to confirm the second one. Y intersect Z complements equal to what? Y prime union what? Union Z prime. So let's solve the left-hand side first. Left-hand side. Let's do that. Let me get the intersection between the sets X and Y. 3 is common. Yeah, that's the left-hand side. I want to get Y intersect Z. Y intersect Z. That will be what? That will be 2. 2 is common. That will be 2 and 4. That's the intersection. So let's now get the Y intersect Z complements. So you're going to remove 2, 4 from the universal sets. You're going to remove 2, 4 from the universal set, and that will be what? That will be equal to um, 1, 3, 1, 3, 5, 6, 7, 8, 9, 10. So that's that on that. So let's combine also the other one, y prime, y prime. Let's combine that. We have the value y prime union z prime, y prime union z prime. So let's combine that. So we combine that, we're going to have is a union combinations of those sets. So that would be 1 comma 2. I'm combining y prime and z prime together. So that would be 1 comma 2, 1 comma 2, 5, 6, 7, 8, 9, and 10. So that's my that's a 1 y y union z prime. We combine it. We have 1, 2, 5, 6, 7, 7, 8, 9, 10. That's that. But let's quickly recheck the first one, the left hand side. The left hand side, y intersect z. Y intersect z is equal to what? Y intersect z. 3, 3. We have 3. We have 4. We have 4, 3, 4. So 3, 4 is a common element. 3, 4 is a common element. So then we can get y intersect z prime. Okay, remove 3 and 4 from the universal set. That will be 1, 2, 5, then 6, 7, 8, 9, 10. So that is correct. That is correct. Sorry for the first one I did. That is correct. This one is wrong. Okay. So the first thing you do in this last question, get your y intersect z. Once you do that, then now get y intersect z complements. Okay. So you remove the set of 3,4 from the universal set, and that will give you this one. That's for the right hand side. Then when you do your what do you call it? Your left hand side, the left hand side, um, the left hand side. I think we have done that. This is the right hand side. This is the right hand side. Okay. The left hand side. Y intersect z. Okay. I've done the left hand side is this one. This one is done. Okay. Then y prime union z prime. Y prime union z prime. That is the one here. Y prime union z prime. Y prime union z prime. So combine, we have it combine this one and this one together. Y prime union z prime. So combine this one and this one together, and that will be 1, 2, 5, 5, 6, 7, 8, 9, 10. That's the y prime union z prime, which is the same thing, which is equal to what? Y intersect z complements. So that's that on this question. I want to thank you. Okay, thank you. If you're just coming in, please click on the subscribe button and subscribe. Okay, don't stop there. Begin to give us a thumbs up and begin to watch. Send the links of this video on all your social media platforms. For the returning viewer, please, I want to say thank you once again. Also, share the links of this video on all your social media platforms. At this point, I'm going to drop the cutting of this live section. When we come back later in the evening, then we begin to do the identity, do Venn diagrams, and do sector questions. Okay, set questions. So thank you so much. See you in the evening by the grace of God. Bye bye. Thank you.